We are the Bushel capstone team for spring semester 2020 at North Dakota State University. Our team is made up of 4 seniors in the computer science program that allow us to split up nicely into 2 teams with Ben and Isaac on one team and Sujin and I on the other. Our sponsors are Max Tran and Lee Reinhardt from Bushel. I just want to say a quick thanks to Max and Lee for being such great help on working with JavaScript and also getting to know Bushel's system. They're very helpful with scheduling and uh, are preparing our further timeline goals for our projects using online resources, and that actually helps a lot with organizing how we're going to complete the project. So thank you for that, guys.
Our sponsor's company is Bushel, which is a startup company based in Fargo. Bushel already did over 600 various projects since 2011. And they also find the grain industry is bigger than farmers. Then Bushel began to focus on software and systems for agriculture industry. Those softwares used by grain facilities and their growers or traders for better business.
So Bushel has a large and complex data pipeline. There are multiple different services and databases that handle and move the data to and from their apps. While going through this process, there can be certain edge cases or unexpected code paths that can produce errors in the data. These errors can either be unwanted changes made to the data or outright removal of some parts of the data. Currently, the only way we have to detect these errors is when they receive complaints about it from the customers. For example, if a ticket goes missing somewhere in the pipeline, the only way Bushel will know is when the grower notices the issue and reports it to the grain company. To remedy this, they need a program that they can run that will detect these errors earlier in their process. Our solution to this problem is a program that will allow Bushel to do a run through of the entire pipeline to simulate data going through and catch any data problems. Our program will send data into the pipeline where it will be stored in their databases and be accessible to the Bushel apps. Our program will then retrieve the data back from the app to our own program. We will then validate the data and automatically send information to Bushel through Slack if any errors are found. And the way we validate the data is by first checking that all of the data made it through. And once that is confirmed, we validate various fields to ensure they are all accurate. So throughout our project, we used 1-week sprints that allowed us to set goals every week and make changes quickly if necessary. Our first sprint was spent just setting up our environment, IDE, and other various requirements to start our project. In our second sprint, we created our data generation methods, which allowed us to create realistic mock data to send in with the help of a couple libraries. In our third sprint, we created an Express server. So we hooked up our data generation methods to this, and it allows the users of this Express API to make a call and specify an amount of tickets they want to be generated randomly. And in our fourth sprint, we connected our program to the Bushel API, which connected us to our app and to their app and allowed us to send data through the pipeline. In our fifth sprint, we created a status endpoint for our API. This endpoint allows the Bushel team to track the amount of tickets created, the amount of times the ticket creation was run, and the status codes of these requests. This is just for their own benefit in tracking what they're doing and seeing what kind of errors come out based on what they've been running. In our sixth sprint, we used another Bushel API to connect to the second half of the pipeline, where we retrieve the data back from their app and databases and pull it back into our program. In our seventh sprint, we created our basic validation method, which checked that no tickets were missing when they came back in from their app. In our 8th sprint, we updated our validation to check the fields of the tickets as well to make sure there were no mismatches or any mutations. And we also started our Slack integration, which would allow us to send messages to Slack from our program. In our 9th sprint, we revised both the validation and Slack integration to completion. In our 10th and final sprint, we created a final endpoint in our API that allows the user to specify an amount of tickets, create those tickets, run it through the system, validate them, and send the Slack messages when errors are found. We also had some struggles in terms of our scheduling throughout. The first main struggle we had, which is mentioned in our midterm presentation, was that we essentially wasted our first week trying to figure out the language Kotlin, and realizing that Kotlin would be more trouble than it was worth, we decided to switch to JavaScript. And another struggle we had was sorting out the work among the members properly from week to week. And a way we remedied this near the end of our project was when we split into teams and started pair programming more often. Splitting the tasks into teams and working together on them helped us solve the problems more efficiently and ensure that everybody was on the same page.
All right, so now we'll go over a quick demo of what our project does. And as you can see, here's our code. We're going to run it quick. And what this will do is it will start an Express server, which we will go to the proper link. And what we're going to do here is we are going to create a certain number of tickets. We're going to go with 10 just to kind of test it and kind of show what it does. Now, what it's done so far is it has created 10 tickets and it has sent it all to the Bushel system. Now, there's a certain little wait time we have here that we wanted to make sure we didn't get any false positives. So we added around a 45-second wait time to ensure that that didn't happen. As you can see here, this is our Slack channel. This is where all of our messages have come in and will come in. We've ran the test a few times, so we've gotten a few errors before, but what we'll see in a few seconds here is some more errors. But as you can see, there's two different types of errors. There's this error right here that says not found in center DB. That means that an error or the ticket that we created wasn't found when we pulled the data from the center again, meaning that the ticket either no longer exists or the IDs were messed up or something else. Now, as you can see, we just got a new batch of tickets. These ones were the most recent tickets we got. And there's also a second type of error that we have, this field mismatch is found. Now, what the field mismatch is found means is that we got the ticket, the IDs match up correctly. However, the fields that we received maybe were a little different than the ones that we created and sent to the API in the first place. So as you can see for this one, the secondary net weight was the field that we got that was different. And the expected number was obviously much different than the received number. So we create this error and send it to the Slack channel. Each error ID has a certain number of field mismatches found possibly. Like this one, for example, has 3 different fields that were mismatched. So each field gets its own field name and own message that it sends with the error. And as you can see, it's all sent to the Slack channel so that the owner of this channel can easily go through, check any errors, and see any problems they may have had and go and try to fix them in the system. Also, in our console, we see that the message was posted, which means that we got 4 errors for this run out of 10 tickets, which is a pretty solid amount and really helps to show what we were able to do. And for some risks and issues that we had, from risks, we obviously didn't want to break Bushel's system. They have a very good system that it works very well, and we didn't want to break anything. So the way around this is Bushel created a test environment for us to kind of mess around with and break stuff. They actually created a system that mangles our data that is sent in or just totally takes it and makes it disappear. A certain amount of tickets are mangled, which means that the data that is sent in is actually changed randomly. We have no idea how it will change or when it will change. Our system or our program just has to automatically figure that out, which is what it is able to do. And the other tickets that are just disappearing, our system also has to make sure that it is able to account for those tickets and send the proper errors when that happens. Another risk we had is we didn't want to access anybody's private information in the Bushel system. The way around that is we spent most of the first half of the semester creating a data generation program that creates realistic mock data that looks similar to any data that we would find in Bushel's system, but isn't actually the data that we would get because we didn't want to access anyone's secure private information that we probably shouldn't have had access to. Now, some issues that we faced, obviously, as was mentioned before, we started using Kotlin and that didn't work out so well. So we switched to JavaScript, which was much more useful for our project and kind of fits what we're doing a lot better. We also encountered a few false positives when we were running our code at the beginning, and when we were putting it all together and sending our information and then receiving it back immediately. Every once in a while, the system maybe wouldn't have processed the information quite fast enough, and when we would try to receive the tickets from their center, we would actually get an error that the ticket didn't exist because it wouldn't have processed it fast enough while our system was running, or our program was trying to run and get the tickets immediately. We had to add a little bit of a wait time, which is what you may have seen during our demo there. That wait time helps us to avoid any false positives that may come up. We also had some other various issues that were mentioned earlier, and a lot of teams maybe had these where scheduling problems were obviously an issue. It's tough to get together when we're all a bunch of seniors. We have very busy schedules, and sometimes it's tough to get together. In the recent weeks, we've had to kind of adapt to the whole coronavirus situation. We no longer can meet in person. We found ways to meet online and over Zoom calls, for example. We've been able to adapt well, though, and I think we've successfully moved along with these issues and kind of overcame them quite well.
Overall, I think the project went pretty well. We were able to prepare our tools and languages used, manage out how we were going to use those, and put in the effort to work on that. So for preparing to use JavaScript, we kind of learned JavaScript on the fly. It wasn't that hard, being somewhat already familiar with Java and other languages. We were able to learn how JavaScript work, and then we were able to use that to generate the mock data. Generating the data was actually really quick and easy to do in JavaScript, thanks to the structure of the data sets that we use, which were JavaScript object notation, which kind of ties in with JavaScript already. And managing the project's goals, we had a lot of help from our sponsors, especially Max, with managing out our project timeline and goals and how we wanted to plan out ahead. Every sprint we were going to work on everything for like 1 week. The benefit of having short sprints is that you can correct issues early and quickly and meet with the sponsors for any change in goals right away. They're also available to talk at any time, like outside of meetings, using Slack and email. So that was really helpful. We used Trello to kind of like draw out a task timeline, and eventually we used Discord to talk online. And the transition to that, I think it worked out pretty well. All the meetings were done online, and I think everyone managed decently with that. So for the effort, well, most of the effort was put into the data generation and validation because that required the most work. That was kind of complex at one point, making the data generation more modular, working on that and validating it for like every single field. The less work was needed for the Slack and router connections. Those are quicker and easier to be able to just figure out how to send the messages and the information to the right URLs. And then at the end, we had to connect everything together, because there were two separate parts that were pretty like big portions of the project, and we put it all into one just run method to keep things simple. And I think that worked out really well. So what's going to happen next for this project? Well, once it's working and done and turned in and set up with the right connections, they can use this project to detect actual errors in the actual data that they have moving through their whole system. And once they do connect it to a database, it'll be even easier for them to keep track of past error logs and actual data with errors in it, and that'll store things better. Because right now we don't need a database to store it. We have it all stored like either locally and messages on Slack. And eventually they might even do something with the user interface, such as like a data endpoint where you can just have like a display showing things like, hey, how much of this data has been moved through this error system, if any. And then for the validation part, they can make it even more modular. So that applies to not just certain JSON data files, but it could apply to like probably messages and other stuff like that. So the error solving part will need to be evolved and eventually created to be even more generic and for just kind of everything.